let's look now at an example of rectilinear motion. Okay, let's look at this as a simple example here of the application of the equations of motion. So you have a car that is in figure 2.2, moves in a straight line such that for a short time its velocity is defined by this function. V is equal to 3t squared plus 2t in feet per second, where t is in seconds. Determine its position and acceleration at t equals to 3 seconds, when t is equal to 0, when the position s is 0. Okay, so basically what we're saying is that the velocity of this vehicle has this function. So it's not that, you know, it's traveling 55 miles an hour or so like that. No. This thing is accelerating. It's changing the velocity as a function of time. And in fact, the velocity changes proportional to the square of time. So we have a definite equation in there for motion. So how do we solve this? The first thing we have to do is to establish some coordinate system, and the position coordinate extends from the fixed origin O to the car, positive to the right. The position, since the velocity is a function of time, the car's position can be determined from the definition of velocity, which is v is ds dt. And of course, since this equation relates to the velocity to the position and t, and we know that s is equal to 0 when t is equal to 0, we have, so this is the equation of the velocity. The question is, knowing the equation of the velocity, can we find out the position? And the answer is yes. So v is ds dt, and that function is the velocity function, which is function of time. If you integrate between s0 and s, and between 0 and t, you will have that s, so you integrate s, so between 0 and s is going to be equal to, so you have, this is the 3 times divided by n plus 1, so you have, so this would be 3, this is y, so 3 divided by 3 plus 2t squared divided by 3, no, by 2, so 2t squared divided by 2 is just t squared, and the other one is just r cubic, so it's 0, between 0 and t, s is t cubic plus t squared. So that's how the position is changed. So now, based on that, we have the position is, now when t is equal to 3 seconds, when t is equal to 3 seconds, you could replace in the equation of s. See here, t cubic minus t squared. So if we replace that, we get 36 feet where it is. You see, this is the acceleration now. If we know the velocity that is a function of time, the acceleration could be determined by the differentiation of that. So dv dt is the acceleration. So since the equation relates a, v, and t, you have that the acceleration is dv dt. This is equal to dv dt but of the function that we have, 3 squared plus 2t. The derivative then is 6t plus 2. So if you have this, if you have the velocity as a function of time, then it follows that doing this way, the acceleration is 6t plus 2. And when t is equal to 3 seconds, you have 6 times 3 plus 2, 20 feet per second. Okay, so this is the, in this case, for this case, we cannot use constant acceleration. Why is that? Because the acceleration, this is a function of time. In fact, in this case, it's 6t plus 2. It's not a number. Okay, any questions? So let's stop that example here.